Hello, everyone. Today we're going to talk about the operational and budgetary impacts of the CARB ACF regulation. This is part 3 of a 5-part video series regarding the state and local government regulation component. I would like to thank Clean Cities, especially the Sacramento Clean Cities Coalition, as they helped us put this video series together, along with East Bay Clean Cities Coalition, the Silicon Valley Clean Cities Coalition, NAFA, and the Municipal Equipment Maintenance Association, MEMA, both Northern California and Southern California chapters. I'm David Rentschler with the City of Fairfield, and we also have David Worthington with the County of Santa Clara. So let's talk about what we're going to talk about today. We're going to go over internal and external collaboration, ZEV refueling infrastructure planning, cost example, the charging infrastructure consumption, public hydrogen fuel infrastructure, overall compliance cost example, some operational challenges, and we're going to discuss some of the regulatory language. So let's start out with the collaboration. So if you're the fleet manager or the fleet management division, in order to put your budget document together, you're going to need to collaborate with, in our estimate, at least 22 different areas. So I've got them all on the screen here. You're more than welcome to come back and look at them later, but these are just what we came up with in our projects.
So this is an example of the zero emissions vehicle infrastructure you're going to need to refuel these types of vehicles. This is an example of a decentralized fleet covering an operational area of approximately 1,300 square miles. There's 454 trucks, vans, SUVs, and specialty truck designs that apply to the Advanced Clean Fleets regulation. There are parking locations. There's 47 overnight locations. 39 of them are owned facilities, 8 are leased, which is very important. 12 facilities lack sufficient local grid capacity to meet charging needs for electric zero emissions vehicles, and 1 facility has no excess local grid capacity. Most of the vehicles are calculated to need to be charged between 6 to 10 hours per day, especially overnight, depending on their battery size in the vehicles. The charge time is dependent upon the charging station kilowatt hour rating, maximum kilowatt battery capacity of each vehicle, and what their daily use is in regards to energy from those battery systems. And this is a cost estimate for those 454 trucks. It's broken up by the different types of trucks. These particular ones are trucks and vans, 3/4 ton to 1 ton, 1 ton and above, medium and heavy duty. As you will see here, just for the charging station infrastructure, the 5-year forecast is $28 million. It does not include the acquisition costs of the zero emissions vehicles or any maintenance facility remodels or building new maintenance fleet facilities, training for the staff, or in regards to damaged electric vehicles, special consideration for being able to handle those vehicles, training, certification, locations, things like that.
So let's just talk about how much that electricity consumption is. So for those 454 trucks, each day, they will use the same amount of electricity as 7 Empire State Buildings, or between 28,000 and 47,000 homes. That's a lot of electricity that you're going to be putting through.
Real quick, we'll talk about hydrogen fuel infrastructure, because that is one of the zero emissions vehicle types that is a replacement vehicle under this regulation. As an example, in the greater San Jose area, the public hydrogen fueling stations, we have 7 of them. Of those 7, 2 are offline, have been offline for quite a while. We do have some future stations that are going through permitting processes that will add an additional 3 stations. None of these stations are designed for medium or heavy-duty truck usage or the length of a truck and trailer to be able to pull into the stations and refuel without blocking vehicle access routes at those stations. Very important that when you're looking for public hydrogen fuel stations near your operations, that you do look at how much room is available at that station, the specifications of the station. Most of them that have been installed in California are really designed to cater to light duty vehicles, sedans, and light duty pickups. As an example, the amount of infrastructure, public infrastructure that's been installed in California since 2009 is only 79 public fueling stations. And to give you an idea how that compares to gasoline, diesel, propane, compressed natural gas, there's approximately 10,000 public stations that support refueling vehicles that use that type of fuel. The other challenge with the hydrogen fuel stations is on average, these stations are down each day and offline due to maintenance, repairs, and other various reasons. They need more attention than a regular gasoline or a diesel fuel station. Hydrogen fuel station costs. They cost between $1.5 and $7 million per station, depending on how much you need to compress the hydrogen down to. There are 2 standards, 35 MPa and 70 MPa, which the 70 MPa is approximately 10,000 PSA and 35 is around 6,000 PSA. The 10 PSA requires additional compressors at the station, storage tank differences. And again, the average is between $1.5 and $7 million, not including the cost of the land that they sit on. The more expensive station design at the $7 million end of the spectrum is for the stations that actually will support medium and heavy duty trucks better than the lower costs. Currently, hydrogen costs between 2.5 and 5 times more costly than gasoline or diesel, depending on the vehicle design. Just like regular gasoline and diesel trucks, the larger the truck, the heavier the load, the less miles per gallon that they get. Deployment of the hydrogen fuel cell electric trucks in the fleet are dependent upon manufacturer availability and public refueling infrastructure. Most fleets are not going to go the hydrogen route unless they either have private hydrogen fuel stations that they can depend upon or a public network. Most of the trucks that will be in medium to the smaller classes of heavy duty vehicles will not be available until 2026 for sale in California.
So let's talk a little bit about overall compliance cost. Here on this map is the City of Fairfield Corporation Yard. Everything to the left of the red line is currently developed, and everything to the right of the red line that is colored there is currently bare dirt. So some things to consider is that currently you have a 6-inch wide painted line on the asphalt and in between parking spaces. And with your medium and heavy duty vehicles, you're going to have pull-through parking. Chances are you have that now. Trucks and trailers, dump trucks, and so forth. So now you're going to lose about 3 feet of, you're going to have a raised concrete with bollards for your electric dispensers. Now, if you choose to do a combined charger and dispenser together, you're going to need about 48 inches. However, we chose to go with a separate charge box and remote dispenser. So we've lost approximately 25% of our parking spaces. And then we're going to need to put in, we have a 90-foot by 60-foot pad that's taking up where we would normally park 10 45-foot buses. That spot is where our switch gear is going to go. So we're actually going to have to expand to the right side of that line now. so that we can have the adequate space to put the charging infrastructure, as well as adding on to our shop, as there's some requirements for large electric vehicles running on 800 volts AC. And we don't have the ability to do that in this building, so we're going to have to add on to make 4 oversized bays. You'll see a couple of pictures here in a minute of some of the reasons for that. And so that throws in the whole turning movements and traffic flow through our yard. And so we're going to have to relocate a couple of buildings and so forth. So this project now has an ROM at the full build out in 20 years of $82 million. So some of the operational challenges, temporary charging and or backup power. So if you're running our current electrification plan has us down for 3 2 megawatt diesel generators for backup power when we're at full build out, so that we have enough power to charge the vehicles we deemed as essential. That's not everything. That's just the essential vehicles. So, that's 6 megawatts of power. Uh, and so, as we're moving forward with our electrification, we need some temporary charging because it's going to be mid 25 before our first phase of chargers are installed. So we looked at several different options. There was the company in the top left there. We didn't check with them, but we did check with a company that does uh, mobile charging. They come out with a trailer. It's got a charger and a big battery pack, and they charge up your vehicles once a day. They quoted us for the first electric vehicles. We got the 3 Lightnings and 1 E-Transit last year. They quoted us $14,000 a month, and that was to come out once a day and charge all 4 vehicles. Wasn't really something that we were willing to pay. On the right hand upper corner, we have the Danner MPS. It's a good source of being a mobile charging site or being a piece of equipment off-road. However, the largest one is a 500 megabyte, or I mean, a 500 megawatt battery. And the buses that we have a 686 uh, kilowatt battery, and we need to put 548 kilowatt hours back into the battery on the bus overnight. So that's not going to work for us. In the lower left, we have an EV ARC. It's a great piece of equipment if you're going to do level 2 charging, light duty, and you're going to charge overnight. Solar panels, self-contained battery. However, they don't have a level 3 option as of right now, and they definitely can't put 548 kilowatt hours back into a bus overnight. The bottom right is a hydrogen fuel cell generator. We looked into a 600 kilowatt setup for us here, and it's 2 40-foot containers. Inside those containers are a couple of small hydrogen tanks and the hydrogen fuel cell generators. Now, there was a third 40-foot container that's needed to operate that system, and it's a methanol fuel tank. And so that fuel runs the chemical process, and somehow you end up with electricity. Well, it's the costs we got were $12 million up front, and approximately $2,300 to $2,500 per day of methanol would be needed to produce that 600 kilowatts. So that would give us we could run 3 200K chargers off of that, and that wasn't viable for us. So in the center at the top is a propane powered generator that's on a trailer uh, and a 200 kilowatt uh, charger on the back of the trailer. So we can charge 2 buses with this and overnight and get that electricity back into the battery buses that we need. It does have a self-contained 6 100-gallon propane tanks. However, some challenges we found with this. One, it was cheaper. It's 1.3 million. We can charge 2 buses with it. And the challenge we're running into now is getting a permit to operate it, because even though it's a portable and you would think it would be under the portable equipment registration program, our air district does not allow that because it's going to be in one place. We need to get a authority to construct and a permit to operate, just like if it was a normal stationary generator. Next. So continuing with those challenges, some of the infrastructure, we've got some pictures up here. Expect to have long runs of large electrical conduit and a lot of disruption in your yard while this is happening. So all those things really need to be taken into consideration, and think about how you're going to protect that charging equipment. I mentioned the 3-foot wide raised concrete with bollards in between your parking spaces. There are other options, but depending on if you have to have pull-through parking or not. Next.
So the other part of implementing zero emissions vehicle technology is safety. For the battery electric medium and heavy duty trucks, we're going to need a 10-foot clearance between the truck itself and the next closest metal object. Well, as most fleet facilities have employed best practices, we've moved hoses, electrical cord reels, and other things to the roof of our facilities so they hang down, but during normal business operations, they retract up and out of the way of anything, especially for tripping hazards. Unfortunately, all that metal hanging down from the roof reduces the distance between a medium heavy duty truck or bus and the roof of the facility. So when you raise the vehicle up on a lift, you don't have the 10-foot clearance. This also goes for the roll-up doors in the front and sides of your work bay area. Typically, most facilities are very efficient in the use of space, and we have as minimal space as we can between work bays to facilitate more vehicles being able to be worked on inside a facility instead of outside. So again, we don't have normally a 10-foot clearance between the battery electric vehicle and the next closest object. And then finally, you do have such things as fall protection. Those systems, as shown on the right in this slide, they're also going to require a 10-foot distance between them and the next closest metal object. So you need to be looking at your facilities and determining what changes you can make to be able to work on these vehicles and what changes are going to require the roof to be raised, a remodel of the facility, or in some instances, a brand new facility built and constructed just to be able to perform maintenance on these battery electric vehicles. That also goes for the hydrogen fuel cell vehicles. You need to be looking at those under the same safety protocols as you would a compressed natural gas vehicle, where you're going to need fans in the facility, special protocols for safety in order to make sure all your workers and visitors to your facilities are safe. Training is very important. We've been dealing with hybrid and all-electric sedans for some time now, but now we're getting into much higher voltages and amperage systems on these medium and heavy-duty trucks and buses. So our staff are going to need to be trained in high voltage systems, contact release, arc flash, everything that's related to high voltage and amperages, being able to jump an air gap of a substantial distance and hit the next metal object, or unfortunately, a person that may be standing nearby and doesn't have all the proper personal protective equipment on. So you need to go into developing your training program to a different extent. You're going to need to develop new SOPs, implementation plan, tracking of all the certifications that your mechanics and technicians are going to need. And then you're also going to need to look at the possibility of creating two or more new job classifications, because the skills, knowledge, and experience needed are significantly different than what we currently have in our job classifications for the work we do on diesel, propane, and gasoline powered vehicles. Some of these job classifications may only need edits to them to add additional information and certification requirements, but others are probably going to need a brand new job classification created. You also need to consider higher training costs. A lot of the manufacturers are going to centralize the training for these type of vehicles, so you may need to be sending your mechanics and technicians out of state for the training, or over extensive distances that require travel expenses that you may not normally incur. And then the repeatability of the training. As far as high voltage arc flash and contact release, your mechanics and technicians are going to need to go through that training annually. So they're going to need to spend a number of hours going through that training, recertifying, and making sure that they're up to the latest safety standards and protocols related to handling these type of vehicles. The training also goes beyond your own team members. You need to be looking at, if you contract out for towing services, you need to ensure that their staff are trained on how to handle these type of vehicles. It has happened where a battery electric vehicle damaged in an accident has been towed away from the accident scene and then actually caught on fire on the back of a tow truck. These tow truck companies need to be educated on what they're dealing with, especially when we get into the more larger battery packs, higher voltage capacities and amperages. One of the things a lot of people don't think about is most of these battery electric vehicles use regenerative braking to recharge the battery and extend the range of the vehicle. But when the vehicle is parked on the side of the road and it's damaged in any way or isn't functioning, as you're moving that vehicle to load on a tow truck, you're actually producing electricity through the system, and you need to make sure that the vehicle's not damaged in a way that electricity goes someplace that it wasn't designed to go. Again, job description changes, certification, and high voltage. The middle slide illustrates the specific OSHA and NFPA training requirements for safety. So you have those numbers to look up that information.
So some of the other operational challenges, probably one of the biggest for battery range is going to be take home. If a vehicle's being taken home, any of that commute mileage is going to use up their battery range. And if charging at an employee's residence is not realistic, which for most government agencies, that would be a problem, you're not going to put a government paid for EV charger at someone's personal residence. And then, so what about emergency operations? Because sometimes you can go on for days and you'll have limited recharging opportunities. If you have the mobile charging trailer, or if you have the mobile generator with the DC fast charger on it, you might be able to help in those emergency operations. However, you may not always have access to those. What about interruptions? So one of the issues we came across early in our pilot programs were when you have a power interruption to the EV charger, does the EV charger notify someone? Is there a text or an email that goes to an employee that has the ability to go out and either restart that charging session by unplugging the vehicle, plugging it back in, authorizing through the RFID card or however you do that? Or does the charger just automatically restart the charging session when the power comes back on? So if you don't have staff for that, that can be a problem. So the next one is I want to talk about is warranties. ZEV warranties start when the vehicle's delivered, so not when it's put into service. So a lot of our diesel vehicles, we have warranty deals with the OEMs. We get the vehicle delivered, and it may be 2 weeks or a month before it's put into service, and the warranty starts once it's put into service. ZEVs are not that way. So if you have any delays that cause the ZEV to need to be stored, which it's very possible you could end up with a ZEV on your lot and have it in storage while you're waiting on your infrastructure. Could be up to 5 years if you took advantage of the full extensions available. So when the ZEV is in storage, what about the tires? The tires are going to get old. You might have to replace them. Software upgrades. EVs have firmware updates and software over-the-air upgrades that are done constantly. Is there going to be a storage facility cost? And then how are you going to maintain the batteries while they're in storage? So also changes in charging technology or even connectors. If you've been paying attention, Ford and General Motors and some others are looking at going to the new Tesla plug versus the CCS. So does the chargers that are being sold during that storage time, they may change, and then the plugs may not fit. Next. So again, with all of the parts of this series, we provide regulatory language and some reference documentation. Please highly encourage you to visit all three of these links so that you can look at what the ACF regulation says for yourself. You can also sign up for emails with CARB. Their listserv, we have a link right here. Just click on the subscribe button and pick the portions of the regulations you want to subscribe to, and you'll get email updates as they come out.
So thank you again to the Clean Cities Coalitions and fleet associations that made this recording possible. Even though you have two presenters, there's a lot of people and fleet managers from the state of California that have contributed to the information that we've included in these slides. Again, thank you to the Sacramento Clean Cities Coalition that arranged all this, and then the support from the East Bay Clean Cities Coalition, Long Beach and Silicon Valley Clean Cities Coalitions, and also the members of NAFA and MEMA, which again contributed to all the information that we've shared in this webinar series. Please consider supporting these coalitions and fleet associations. Below is our contact information. If you have any questions, please reach out. We'll answer them to the best of our abilities. Thank you again for joining us for part 3 of this 5-part video series. We will be putting these series up and making them available to everyone. Thank you very much. Have a great day.